Hey, welcome everybody. And what do we have here? It's a Mazda, red Mazda car. So as you can see, what we will go through in this Houdini hip file study, how to create this demolition and fragmentation with some debris, smoke and dust. So let's have another look. This was created in 3ds Max with Craft Studio. It's easier to drive through that plugin. This is another view, and as you can see, we have the car, the ground, the fragmentation, dust and the smoke. Okay, and this is the network, the hip file, and it can be available on my Patreon page, Fadi VFX. This is the file. You have the car and you will have the hip file also. This is the car and this is the hip file. This is the link for the video. So I appreciate your joining and supporting me over there. So overview of the file, we have environment light, couple of cameras, and this is the render output. This is the Mazda FBX file, and it's being animated. Let's take one of the cameras. Quick animation, so we are focusing when it do the drifting and circling here. And the red one is where all of the network, and this is where we will start. Starting from the top, we imported all of the car geometry, as you can see here. And the way I imported it, if you go to the Mazda, this is just a single frame, no movement. But in here in the Mazda, because I have all of these files and the material, so what I did the following: I select all of these nodes representing the car, and I run the script merge FBX. Edit tool. This is the script. I share it in one of my earlier tutorial. So when I press it, it will create for the car this network with all of the connection and the material, merging it, coloring, and then merging all of it. I added a normal, and this is the out for the car, and it's being animated. So to make it faster, I cache it again as PGO. So it's moving now. Okay, we'll start in the middle. What I want the ground to fracture where we'll be having the tires. Okay, so we created a box. Let's go to the box. This is the area where it will be fractured. I give it a black color, so it's in black. And on the other side, I kept only the wires. Let's go to that frame here. So as you can see, I just kept the tires. We calculated the velocity. I will be using it later, and I give it a red color, so I will be transferring the red color from the tires to the ground using a solver. So we'll go inside. This is the previous frame. This is the second input. As you can see here, this is the second input going from the tire. So I'm transferring the CD, the color. I'm putting it in the output. Just go here, and it will start to draw the red color and keeping it because it's solving. Let's go outside and have a look. Good. Then I added a time shift to the last frame, so it will capture all of the coloring. So this is the time shift. Give it a second. So this is the outcome, and we will use the red area on the ground to be fractured. Okay, so from the box I run RBD material fracture according to the scattering point on the density of the red area. Just give it a second. So as you can see, we have points according to CD, total of 3000, and this is the outcome. So the fracture will be concentrated in the red area. I created an active attribute, so the small area chunks where the tire will move will be active and will be participate in the simulation, and the area that's black or outside where the tire will be, it will be inactive. So we'll remember this step. Let's give it a color and we come back to it. So in order to transfer this attribute active, I want to create it here. As the tire will move, it will start to activate the chunks. So if you remember here, we did the tire. Let's go here, these tires. I give them a mirror, connectivity, and running through a for each loop. I added a convex hull. Let's just remove that one for the tire, and then transform it a little bit in the side, give it a remesh, reduce its polygon, and then export it out. So it's moving now. I transform it a little bit up so it will intersect with the ground, and then I merge it with the rest of this funky car. Okay, so how we created this car? With a null, I clip the top because I don't want to have a heavy geometry. I'm just interested by the areas that's near to the ground where I can transfer the active attribute. Then I added a polyfill, so I don't have open geometry, and I didn't bother about the shape being irregular because I created a VDB from it and then convert it back to polygon, and of course I cache it. So we have this and we have the tire, we merge them both together, and we have this ugly shape which is useful for us because here I add attribute that's called active, and pay attention, active, and the value is 1 and the default is 0. Okay, so everywhere here it is 1, and here when we created the other attribute, it's active integer, but we make the value 0. That's for the ground. Yeah, give it a second. So here we are 0 and this is 1, and then we will transfer attribute transfer here. So if I can view it, active, we got this. So every where we have a red color, it will be 1, purple color will be 0 and it will be animated. Yeah, it's taking time. So we back it, this one no need, and then I cache it again, just one frame, single frame. I run, but then what did I do here? This was the first trial. If you want to use it, you can. The other way I did it, immediately I connected from the RBD fracture to the RBD config, and the constraint also, it's a glue constraint, and the proxy one I use it with the active being transferred from the car to the ground. So here the only thing I added to the RBD config is I configured it as a concrete lightweight. Then I run the RBD solver, but before that, what I have as collision geometry, I have the car and the wheels. So here we don't have a space, so it will make sure that the fragment will collide with it. And here we go to the first frame. Only I added a speed limit of 5 so they don't fly very far. I added an active attribute in the property. The collision is deforming, so it will capture the animation. I ground and make it a little bit lower. Added some drag and drag spin. Just activate it. I didn't use it, but I export the rotation and the edge and the velocity. Here I don't have a movement till I reach frame 75 or 80, so I'm switching between the non-animated ground, and when we reach frame 74 it should be 75 because above 74, so at 75 we will see the fragments being simulated. See how it flipped? So this is the animation. Of the car. Okay, it's a better view with some shadow. So that's the fragmentation phase. Now we'll talk about building up the secondary fragmentation and the dust and possibly the smoke. So for secondary fragmentation, because these are bigger chunks, I want some fragments that will be created in between these two chunks. So it's on this surface, the inside surface. Okay, so let's find it. Let's go down here, fix one like this. So where did we stop? We stopped here. We stopped here. Let's put it like this. Now these are backed primitives, so I need to unback them. So now they are unbacked. So I cache them again, and I put an out. No need for this node. And Debro source. This is where I created the collision. So I'm just merging the fragments, the car. Okay, but here I did the same. It's here. I unback, I blasted everything that's not inside, so I have the inside faces, and I branch it to a debris source. Let's go to the first frame. So in the debris source I animated the density so it's high, then slowly go down and decrease, and I remove all unused points. So it's something like this. So this is how it will look. So these are the source for all the small debris, and because I decrease the density scale, it's not going crazy. Then I added a debris pieces. I scaled them for a proper size. Just give them a second. The debris pieces are just a box with some RBD fragmentation, grouping, and then attribute promote all the way down. We have some pieces together. And then I copy to the points. Let's go to the points. Here we go. This setup you can take it from the Pyro instance for the debris. Okay, so I'm instancing according to the point ID and variant, a random geometry, as you can see. So these will be having their own unique name and will be involved in the RBD simulation, just the standard one, and then we cache the result, and this is the result. And this simulation is the heaviest one because these small chunks are colliding with the ground, the car, the other fragments, so it's a crazy one. That's why better you cache it. This is where the car hit the small pieces. As you can see. Very nice distribution, and this goes to the render output. Here, if you remember, I unback it, blasted, I keep the inside faces, same another debris source that I cache again with different setting, and I ended up with this. So this will be the source for the pop network and the dust. So I added the point velocity with some curve noise. As you can see, chaotic. I deleted unnecessarily attribute age and life so it doesn't affect the pop simulation. In the pop simulation I have, let me cancel, go to the first frame. I have my car, ground and fragments. The pop object, I'm sourcing all the points with 10,000 impulse, some force in the up with some amplitude noise, speed limit with some variation, little bit of wind with some variation, and advect by volume. Remember this one, this node, because we will use it, use the velocity from the Pyro simulation to add it here. Bob advect by volume, just 0.9 I'm adding, little bit tiny drag, and we run the solver and I cache it. This is how it looks. So it's not only running through the simulation, also it's been affected by the Pyro velocity field. And I remove the unnecessarily attribute, and I put an output for the dust. So this will be the dust. So we talk about this, we talk about this, we talk about this, and we talked about the fragments, secondary fragments and smoke, and this is the smoke. We'll talk about it now. So for the smoke part, it's straightforward. All of our preparation is already being done, but let's go from here. You have the car, the polyfill, VDB, bone deform. So the VDB is static frame and capturing its animation from the original FBX, and I added a cache for it, so it run fast. Then I went down here. You remember the Bob network we created here for the dust. I created a similar one, but a tiny one on the box. I give it a color as you remember, and we transfer the attribute. Then I scatter, Ctrl G. It's in black. Attribute triangle for the speed length. I first added the ID for the PT num. Measured the length of the velocity, and if the speed is less than 1, then remove the points. So we don't have point at the beginning, and when we start to have some speed, we will capture some points. So these points, that's having a higher speed. And I played with the velocity, some conical noise, and I run through another Bob network. Nothing special, just some sourcing. Then I cache it. It looks like this. So this will be used to create the dust as a source. So I went down here, attribute delete, I removed the unnecessarily one, but I kept the age and ID and speed and velocity. And if the age is less than greater than 1, then remove the points so they don't stick for a long. So being deleted, as you can see. A Pyro source for density and temperature only, no fire. Changing the velocity, adding volume rasterize, and then running it through Pyro solver with some collision geometry, mainly the car. Nothing added here, and then I cache it. And as you can see, we have the velocity field that's being used in the dust. So this is the smoke output, and by this we completed the setup. So I have the smoke in here, we imported. I give it a Pyro look node to make it between white to gray, convert it to VDB, and then caching it again. So this is how it looks. And the material I use, because I rendered it with Karma XPU, and the material I use this one, the XPU Pyro preview node. So this is the one I use, not this one, not this one, this one, which I added to the top here in the render. Should be here anyway, but I think later on I connected it, but this is the one we use. The small debris, I give it gray color. Fragments and the dust, I added the alpha according to the age. I calculated the age, or the, like a timing age, and when it reach 1 it will disappear. And this is the grid. Just small thing. And here I have all my caches, and this is the Rob Karma render as XPU. These are the frames as JPEG I render it, and this is the outcome from multiple camera view. So hopefully you enjoyed this quick demonstration, and you have the file to play with on my Patreon, where I'll appreciate your support and your comment and share and spreading of the information. See the reflection of the glass, look very nice. That's cool. These are previous tests, and this one, after this one, is my upcoming tutorial also, for a door that open and the water rush out of it. This will be coming next. So hopefully you enjoy it, and thank you very much.